Alright, so today's topic is we're looking at sets, okay? Set theory and the use of Venn diagrams to illustrate sets. Now, a set is a collection of well-defined objects, okay? Set is a collection of well-defined objects. Alright, now look at this question. It's a past question from the WAEC. So it says the sets A, B, and C are subsets of the universal set symbolized by this capital letter U. So this is a symbol for universal set, and the elements are 1, 2, 3, so on and so forth to 14. All right, now this is a set. The subset are smaller sets brought out of the universal set. So the all right, so we're looking at the subset. So we have some subset like set A. Subsets are brought out of the universal set. So the universal set is like the parent set, okay? Parent set. So look at, I'm going to list out the universal set. So the symbol universal set. All right, so you have the curly braces and you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so that is how we list out the universal set. Is the parent set. Out of this parent set, we have smaller sets or called subsets. So look at the set of even numbers. That should be like that: 2, 4, 6, 8, 10, 12, 14. All right, so we have this. These are the even numbers. So the subset A, even numbers brought out of the universal set. That's 2, 4, 6, 8, 10, 12, 14. You have to stop at 14 because no subset can come out of the universal set or can go beyond the universal set. Now the subset B is taken to be the factors of 24. So look at the universal set. What are the factors of 24 from out of the universal set? We have 1, 3, 4, 6, 8, 12. Okay, so these are the factors of 24. One can divide into 24, same as 2, 3, 4, 6, 8, and 12. All right, so those are the subsets, even numbers out of the universal set, which is 1 to 14. Even numbers are 2, 4, 6, 8, 10, 12, 14. The factors of 24 from out of the universal set are 1, 2, 3, 6, 8, 12. Those are numbers that can divide into 24. And finally, the subset C is already stated. It's already listed out for us. So subset C, let me just release them. So you have the curly braces, you have your members 3, 6, 9, and 12. So these numbers are known as the elements or the members of set C. All right, so we have all of our subsets. We've listed the elements of. So we have so we have our so list the elements of set A and B. So set A, these are the elements of set A brought out of the universal set. These are the elements of set B. Now let's illustrate the information on the Venn diagram. Illustrate the information on the Venn diagram. So a Venn diagram is simply a rectangle, okay, that is labeled. So this is a symbol for universal set. You can use the symbol E or the symbol U. It's a rectangle. Please draw with your ruler. So we have a rectangle. All right. So you have something like that. All right. So rectangle, and we have ovals. We're using ovals to show the. All right. So we have our ovals. Now you label the circles or ovals. Now we have just 2 ovals because we have just 2. Actually, we have 3 sets. We have 3 sets, so there should be a 3rd oval here. I'm going to put in my 3rd oval. All right, this is very rough work. All right, so I'm going to label it C. Just cut it out, C there, and then I should have my label A. Okay, this is just a rough work. And now we'll start with the triple intersection. Right here we have the intersection of all sets A, B, C, where they overlap. So you come here and think, where are the elements that you can see everywhere? So I can see 3, no, it's only 6. Only 6 is the common. All right, so let's get to it now. So let's this is the neater work. So this point of intersection of all set A, set B, and set C, they intersect at just this point. So what's the element that is common to all of them? 6 and 12, 6 and 12, 6 and 12. So we have just 6 and 12 in this point here, right there, just 6 and 12. Now what's common to only A and B here, right here? What's common to only A and B? That's 2, 4, and 8. You can check it out. 2, 4, 8, 2, 4, 8. There's no 2, 4, 8 here, okay? Now what's common to B and C? It's just... Alright, so just between A and B is 2, 4, 8. Now between B and C, what's common? The common element between set B and set C. You observe is just 3. 3, 3. That's the only common element between sets B and C. Just 3. Nothing else is common. But I can see 6. Do you see 6 there? I think 6 should also be common. But you see 6 is already here. 6 is already here. So 6 is already part of that. Now what's common between A and C? Common between A and C? There's no common element between A and C. No common element between A and C except 6 and 12, which is already written. So 6 and 12 is already there.